everyone. Welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up 66 is on the screen. Let's get started, please. Shouldn't take you long. Copy and go. All right, let's get the show on the road. Let's see, who haven't we called on? I think Gio we haven't called on. All right, Gio. Complete the square for number 1. What do I do? Parentheses. So that gives me what? $144. All right. And what'd you get for the factors? X plus 12, which is x plus 12 squared. All right, not bad. Thank you, Gio. Pass on one for 2A. What'd you get for 2A? Joseph. Six I plus minus. Hands if you got that. Looks about right. 2B. Pass them one. Elijah. That is correct. Hands if you got that. All right. 2C. Pass them one. Mario. Approximately. Or walk us through it between what two perfect square numbers is 23 found? 16 and 25. So that means if we take the smallest number and take the square root, then it's going to be 4 point something. All right, how we find that something? Subtract 23 from 16, that's 7. Divided by 25 minus 16, that's 9. Therefore, 7 divided by 9 does not fit in there, out of 0. 7, that's 63. 7, and it repeats. So this is 4.7 bar. Right now, this should be automatic. All right. Yeah, if you round it to 4.8, that's fine, I guess. Let's go to number 3. Mario, pass them one. Enrique, walk us through that one. Power Rangers. Hold on. We got negative 24 and negative 5. Negative 8 and 3. All right, then drop x squared. Drop negative 24. Instead of that, negative 8x plus 3x. That is correct. And then parentheses group. So GCF for this one. X minus 8. So my factors are that is correct. By now that should be automatic. All right, let's go to number 4. Pass someone for number 4. All right, Mario, walk us through this one. Hold on. All right, go. Change it to y. Then we got y plus 7 equals 3x. Then by both sides, we get y plus 7 over 3 equals x. And then yep, flip the variables. That one here, that one there. X plus 7 over 3 equals y. And lastly, f of x. F inverse of x. All right, hands if you got that. All right, not bad. Copy the agenda, please. Warm-up number 66. Tonight we do have our 5 transformations, so make sure get that done. Today we are moving on. All right. And here's your code for today's home plate access, IGWY6. IGWY6. All right. So last time we turned this in, it was 3 transformations. Tonight are these, 5 of them. So make sure you, all right, get a Cornell note ready, please. Also, come get 2 graph papers, and you are going to need your Chromebook. Make sure you have that available. All right, shall we? Here we go. I can transform a function using different parameters. Today we're going to finish off, guys, with the last parameter that we need. So make sure you stay on top of things. Here we go. So, first of all, we're still in the middle of functions, so remind your neighbor the definition for functions. Make sure that they know exactly what we're talking about. What are functions? All right, type me your definition on the screen, please. What is a function? Go. All right, something like that. It's a relation with exactly one output for every input. Yes, pretty good, yeah. All right, so from there we ended up with this one, is that correct? And we know what to do to rewrite this by putting in an invisible 1, is that correct? Yes, Mr. Q. So we know how to rewrite this using transformations and then graphing. So I'm going to come back to that one because I want us to get to the one for today. So on your graph paper, get that in front of you. Copy example 2Q on the left side of the new graph. Copy all the words, and then copy this graph onto your graph paper. I'll give you some time. Copy and go. All right. Should be just about done. So we're going to need some space, guys, for some of the work that we're going to do for this. Hold on, let me zoom out. So, first things first, remind your neighbor, it says the graph of f of x equals x cubed is shown. There it is. However, what if I gave you this? And for it to say graph of f of x equals x cubed. Tell your neighbor what to do if it just says to graph that. What do we do first? Yes, let's make a table. So let's do that together. Here we go. I want you to write x, f of x. And again, what values are we going to use, Renzo? That is correct. That's our bread and butter for the rest of the year, unless it's specified. All right, so there it is. So, here we go. X cubed, that means we take the x and cube it. What is negative 2 times negative 2? That's positive 4 times negative 2. That's negative 8. Negative 1 times negative 1 times negative 1 is negative 1. 0, 1, and 8. And that's how we got these 5 points. That's why we label this f of x. So far so good, yes? However, they want us to do a transformation. So, for this one, I'm going to use blue, and I want you to make this table right next to this one. I want you to write x. And you're going to write f of 1/2 x, close parentheses. And since it's the cubic, I'm going to put the little cubic right there. And again, negative 2, negative 1, 0, 1, 2. All right, so now before I do anything, I'm going to write the general rule right here so you guys can see where we're at in regards to a transformation. Our general rule is g of x equals a times f, parentheses, x minus h plus k. Is that correct? But they're asking us to do this transformation. Tell your neighbor what you notice from our general rule for this transformation. What do you guys notice? Talk about your neighbor. What do you guys notice? Renzo, pass someone? Joseph, what do you notice from our general rule to this transformation? There's no k, okay? There's no a, and no h. However, now we have something new inside of the parentheses multiplying x. Everybody see that? Pretty obvious? Okay. So, with that said, how do we do that? Well, let me zoom in. Here we go. We're going to do this together. So, f of, let me change color, sorry. F of 1/2 times x cubed. All right, so what is my x? Negative 2. So that gives me, I'm not going to use the f anymore. I just wanted to see, for you to see where everything's at. So what is 1/2 times negative 2? So that is 1/2 times negative 2 over 1 cubed. So that is negative 2 over 2 cubed, which is negative 1 cubed, which is negative 1. All right, let's do the second one. Here goes. F of 1/2 times negative 1 cubed. So we have 1/2 times negative 1 over 1, which is negative 1/2 cubed, which is, let's see, what is negative 1 times negative 1 times negative 1? Negative 1. What is 2 times 2 times 2? 8. There it is. And of course, f of 1/2 times 0, it's always 0. All right? So now that I showed you how to get those numbers, I want you to find the last two values. Last two values. Go. All right? Show your neighbor what you got for the two last remaining values, then we're going to send it over to Monse and see what she got for the value of 1 of x, and then f of 1/2 x cubed. All right, Monse, what'd you get? 1. Hands if you got 1? 1/8. Okay, my bad. Hands if you got 1/8 for this one? That is correct. How about for the last value? What'd you get? Evelyn, what'd you get on the last one? You haven't finished yet? Okay. Caitlin, what'd you get? 1. Hands if you got 1? All right, let's graph that. Let me zoom out. Here we go. -2 and -1. -2, -1 is right here. -1 and -1/8. I'm going to have to zoom in for that one. -1, -1/8. Very close to the x-axis. 0, 0. 1, 1/8. And 2, 1. All right. So let's connect those. All right. Let me zoom out. Look how beautiful that looks. Let's go. All right. So now that you see the transformation, before we move on, if I was to ask, let's say, Geo, and say, Geo, what happens to the original function when there's a number multiplying x inside of the parentheses of the function, and specifically if it's in fraction form? Talk to the neighbor, what's going to happen to the original function when we have a multiplier which is a fraction form? All right. Now, before you give me an answer, on your notes, write the new, actually, hold on. Send me your notes really quick. I want to see your graph. Screen. Our new general rule looks like that. G of x equals a times f of 1 over b x minus h plus k. Write that down, please. So let's recap on this one. What does k do to the entire function? Tell your neighbor, please. What does k do? Annette, what does k do to the entire function? moves it up and down, so draw your arrows up and down, up if we substitute a positive value in here, or down if we substitute a negative value. Thank you, sir. Gio. You're going home? What? Always on my class, my goodness. It's being recorded as well. Bah. All right, next. What does h do to the entire function? Once again, remind your neighbor. What does h do? All right, Abby, what does h do? Left or the right? So draw an arrow going left or right. Once again, if we substitute a positive value for h, it goes to the right. A negative value for h turns this into a positive in here, and it takes us to the left. All right? All right. Next, with red, A. Remind your neighbor what A does to the entire function. What does A do? Maydim, what does A do to the entire function? Compresses, that's one. Compress or stretch. Okay, it compresses when it's a what, everyone? A fraction or decimal. It stretches when it's a whole number. However, I'm going to add one more word. Look up. That, when we first did all the practice, it did compress and stretch vertically. So now check this out. Now we have a new, do black on this one, a new parameter, which is B. Now, think it through. And notice this one, the 1 stays on the numerator, so all we're substituting values for is for the denominator of that function, that fraction. Now, think it through. Here goes. For A, it compresses and stretches by substituting those values vertically. So tell your neighbor what you would write for B after we did that. Notice that it's going in which direction? Look at the blue. Where is it going? In which direction? Sideways. Is that correct? So talk about your neighbor. What would you write for that next part? Oops, sorry. All right. So, what would we write for that one? Jesus. Oh, okay. He said compress or stretch. And his voice changed. Compress or stretch if we substitute what? Compress, fraction or decimal. Stretch if it's a what? Whole number. However, in which direction, everyone? Horizontally. Horizontally. So now that means it's going sideways, it's stretching it to the sides or compressing it to the center. Ooh, so now we have all 4 different parameters. Pretty good, yeah? All right. So, with that said, now that we have all of them there, give me a second. do a little memory game. How about them apples, yeah? Let's see how well you do. All right? Writing utensils down, you're going to be answering just on your screen. So you're going to be drawing on the screen. Here it goes. Look up, please, and it reads, the graph f of x equals x squared is right here. There it is. There's 5 points. Here's the general rule now. What if we substitute for a -1? Talk it over to your neighbor. What's going to happen to this function if we substitute -1 here? All right, sketch it on the screen, please. I want to see what you think. What's going to happen to that graph when we substitute a -1? All right, so let me go back to our notes really quick. Look up. So what are you going to add, for those of you that missed that question, what shall we add in regards to a little note here for A? What would be a note to remember, guys? Tell your neighbor, what would we add here? When negative A, we what? What do we do to the function? We flip it. Yes. We flip the function. Quick note, just keep that in mind because you are going to encounter those for your home plate. Thank you, Mr. Q. All right, you're welcome. All right, let's move on. Next. Look at that. Again, there's the graph, but now A is +2. Talk it over to your neighbor. Let them know what's going to happen to these points with A +2. Talk it over to your neighbor. Where shall we place those points with +2 of A? Go. All right, sketch it on your screen. All right, so what happened to those points, Joseph? What happened to the points? They stretch, that is correct. All right, let's go to the next one. All right. What happens now when A is 1/2? What would happen now if A is 1/2? Talk to your neighbor. What would happen to that? A is 1/2. All right, graph it on the screen. Looks about right. Here's one from one of your colleagues on your screen. And you got something like that? Yes, that is correct. It compresses. Go to the next one. Look at this one now. What happens if we substitute a 2 for B? What would happen to those points? Talk it over to your neighbor. What happened to those points if we substitute 2 for B? All right. Go ahead and graph it. Let's see what you get. So even though they added an extra point on top, on the left and the right, however, notice the points -2, 4, and 2, 4, they go down to -2, 1, and 2, 1. All right, not bad. Next one. H5. Tell your neighbor what's going to happen to this entire graph with H5. Substitute in H5. All right, graph that on your screen, please. Yes, we move it to the right. It's a positive number. My goodness. All right, let's go to the next one. K negative 7. Tell your neighbor. K negative 7. All right, graph it on the screen. Everyone. Looks like it's moving what? Down, is that correct? All right. So enough of messing around. Let's go to the last one. Hold on. We still have time. And I'll pick someone for this one, and if you get it right, we're done. If not, I'll give you one more. So, tell your neighbor what's going to happen to that original with all those parameters. And I'm going to pick... Jesus and Sammy, they're going to enlighten us with that last one. Let's see how they do. All right. So let's see. Jesus, get us started. What would this do? Flip. How about this one? Stretch horizontally. Sammy, and the last two. Left and 6 up. All right? From 1 to 5, we'll come through, are we, with the 4 different parameters. How we doing? 3, 4, 5s, okay. You need practice, right? So make sure you do your practice tonight with those transformations. We'll continue this tamales. Wait a minute. Tomorrow's Friday, Mario. Let's go.